In this video, I will give the solution for numerical problems 4. The first question is, a water treatment plant with an average flow of Q is equal to 0.044 meter cube per second treats its water with alum. Formula Al2SO4 taken thrice 14H2O at a dose of 25 milligram per liter. Alum coagulation is used to remove particulate matter reduce the concentration of organic matter and reduce the alkalinity of water. If the organic matter concentration is reduced from 8 milligram per liter to 3 milligram per liter, determine the total mass of alkalinity consumed and the total mass of dry solids and the total mass of dry solids removed per day. Okay, so basically they are using alum in order to coagulate the alkalinity. The equation is Al2SO4 taken thrice 14H2O plus 6HCO3 minus is to 2AlOH3 plus 6CO2 plus 14H2O plus 3SO4 2 minus. So if you see, in every mole of 1 mole of alum is consuming 6 moles of bicarbonate. This bicarbonate is nothing but alkalinity, and it is producing 2 moles of aluminum hydroxide. This aluminum hydroxide is solid precipitate. So there are basically 2 solid precipitates. One is aluminum hydroxide and the other is the settlement of organic matter. So these two together will contribute to the total mass of dry solids. So first we calculate how much alkalinity is being consumed. That is the first problem asked. Then later we have to calculate the sum of aluminum hydroxide and organic matter that is being settled per day. Okay. So as we can see from the equation, alum added is at the rate of 0.44. so alum added per day is at the dose of 25 milligram per liter. So in every liter 25 milligrams is added, so 25 milligrams per liter. But how many liters are added in a day? So we have flow rate per second, that is 0.044 meter cube per second. Then we have to multiply it per day. So how many seconds per day? So 24 hours and 3600 seconds per day. So this would be, if you multiply these three, so you should get around so here it is in liters and here it is in meter cubes, so we have to also convert meter cube into liters. So this, if we convert into 10 power 3 liters, so if you multiply all this, you should get around 95.04 kg per day. So this much alum is being added in a day. So now as per the stoichiometry, 1 mole of alum means the molecular weight of alum is 594.35 grams of alum is consuming how much amount? 6 moles. 6 moles of HCO3 means 6 into 1 mole is 61 grams of HCO3 is, or alkalinity is being consumed. Now since we are in a day sending 95.04 kg, how much alkalinity will be consumed? So it is 95.04 into 6 into 61 divided by 594.35. So this would be 58.5 kg per day. So this much alkalinity is being consumed. Next, so this is the first part, total mass of alkalinity that is consumed. The second part, total mass of dry solids. These dry solids are two parts. One is how much aluminum hydroxide is being produced and how much organic matter is being settled. So let us calculate first how much aluminum hydroxide is being settled in a day. So as you can see from the equation, 1 mole of alum produces 2 moles of AlOH3. So 1 mole means 594.35 grams of alum is producing 2 moles of AlOH3, that is 2 into aluminum hydroxide molecular weight is 78 grams of AlOH3 is being produced. Now we want how much alum we are added in a day? 95.04. So 95.04 kg produces how much aluminum hydroxide? So this would be 2 into 78 into 95.04 divided by 4.35. So this should come around 24.95 kg per day, or roughly you can say 25 kg per day. So this is aluminum hydroxide, AlOH3. Next, how much organic matter is being settled? So you can see the entry is 8 milligram per liter and outgoing is 3 milligram per liter. So per every liter, so organics removed is organics removed is equal to 8 minus 3, that is 5 milligram per every liter. But how much liters of water is being processed? So we have to multiply. Okay, so total, this is per liter, so total organics removed, if you multiply it with the flow rate and time, so that is 5 milligram in a liter. But how much liters we sent? 0.044 meter cube per second. This is into 10 power 3 liters per second into day. Day means 24 hours and 3600 seconds. So if you multiply all together, you should get around 19 kg per seconds per day. So kg per day. So this much organics are being removed. So total dry solids removed is, total dry solids removed is equal to the ALOH3, that is 24 point or roughly 25 plus 19. So total around 44 roughly kg per day dry solids are removed. Okay, so this is the first problem. Next, the second question. A coagulation treatment plant, with a maximum flow of 1.5 meter cube per second is dosing alum. Here the alum formula is bit given different. Okay, at 25 milligram per liter. Concentration of suspended solids in raw water is 37 milligram per liter. The effluent suspended solid, concentration is 13 milligram per liter. The sludge content is 1%. Basically this 1% is by value, mass, basically by, and specific gravity of sludge solids is 3. What volume of sludge must be disposed each day? Okay, so a coagulation treatment plant with a maximum flow of 1.5 meter cube. So the flow rate given, so it is Q is equal to 1.5 meter cube per second. So let's say if this is the treatment plant, so the inlet suspended particles is 37 milligram per liter. Concentration raw water, that is 37 milligram per liter. And after passing through the water treatment plant, the outlet effluent suspended concentration is 13 milligram per liter. So this difference in concentration is because a part of the suspended particles are being settled, and this is giving rise to sludge. So out of total volume, 1% is that solid particles. So how much is being settled here? If you take that particles that are being settled, particles settled is 37 minus 13. That is for every liter 24 milligrams for every liter of the flow. Flow is of course 1.5 meter, but every liter of the flow 24 milligrams are being settled. So the dose of alum is given. So if 66, because aluminum, we have 1 mole of, I will write the formula here, Al2SO4 taken twice, 18H2O plus 3Na2CO3, 3Na2SO4 plus 2ALOH taken thrice plus 3CO2 plus 15H2. What we can see from this equation is, for the alum, 1 mole is producing, 1 mole of alum is producing 2 moles of ALOH taken thrice. Then how much alum is being added? In our case, the alum being added is at the rate of 25 milligram per liter. So in a liter. So if 1 mole of alum is, here it is 18H2O, unlike it is 14H2O in this. So the molecular mass is 666 grams of alum is producing 2 moles of ALOH, that is 2 into 78 grams of ALOH. Then if you are adding per every liter 25 milligrams of alum, then this 25 milligrams of alum produces how much ALOH3? So that would be 25 into 2 into 78 divided by, so this would be roughly 6 milligrams. So this 25 milligrams you are being added per a liter. So this 6 milligrams of ALOH3 is deposited per liter of the flow. Then total deposits would be here 24 milligrams per liter deposits plus this 6 milligrams, total deposits per liter, total deposits per liter, that is 24 plus 6, total 30 milligrams per liter solids are being deposited. This is per liter only. Since the flow rate is 1.5 meter cube, you have to multiply so that we get the total deposits. So per day total deposits is equal to 30 milligram per liter into the flow rate is 1.5 meter cube means 10 power 3 liters per second. Then we have to multiply, since we want per day, so into 24 into 3600. If you calculate this, you get around 3888 kg per day. So this is the mass of solids that are being deposited, but along with these solids the sludge also contain water. So in fact it is 1% of the sludge, that is this 3888 kg. Then what about the remaining 90%, which is water, whose mass would be how much? Just simply 99 into 3888 kg. So this would come around 384912 kg. Okay, so what exactly asked in the problem? It is not asked about mass of solids but volume of sludge. So we need to convert this masses, mass of solids and mass of liquid, into volumes. So that is by using density. So volume of solids deposited would be mass by density, that is 3888 by, given that the specific gravity is 3, so we can say the density is 3000. So this would be roughly 1.3 meter cube. Volume of water would be again mass 3000, 3,84,912 kg divided by density of water, that is 1000, will give you the volume in meter cube. So this would be roughly 384.9 meter cube. So total volume, if you sum this, you get roughly 386.2 meter cube per day. So this is the total volume of the sludge, which includes both water and solids. So that's it.